Crack it over there. It's oh shit, that's wrong. That's the wrong naming. Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM. Those were all gang signs, you know what I'm saying? This is the gang sign shit. You know what I'm saying? Well, my thermodynamics exam is tomorrow, so we gotta study. We gotta do all the question papers, and we gotta pass this because we need to take. For my fifth semester, I have some course based on physical chemistry, which I can only attend if I pass this fucking exam tomorrow. So we gotta pass this shit. And I'm not, I'm dead serious. I can't say the N word. I mean, I could, but you know, why you gotta make controversial stuff? Gas reaction. So this was the last question, and for the last question, if I remember, we multiplied the flow of water with density to get kilogram per second. Yeah, multiply to get something right based on kilogram per second. Then we multiply that with the heat capacity of water, with the product of these two, with the change in temperature, giving us the power, which is in joules per second, which directly translates to watts. What? Exactly. Gas reaction, sulfur trioxide. Well, sulfur trioxide is produced in an industrial scale from sulfur and oxygen. For simplicity, let's assume this is one-step reaction. Well, it's not that simple, is it? How? So is that a question? Oh, how many cubic meters of air with uh-huh. I mean, I understood. Like, for a specific volume of air, 21% is oxygen. Temperature is 28 degrees and 335 kilopascals of pressure are required to produce 55 tons of sulfur trioxide. If you calculate a volume excess of O2 at 23%, what the? If you calculate a volume excess for oxygen of 23%, mm, if you calculate a volume excess for oxygen of 23%, I did not understand the question. What do you mean volume excess for oxygen of 23%? What is what just increased? What just happened, bro? What? GPT. Mm, 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 Save. working? I believe it's working. It should be working. Oh, hell yeah. Hell yeah. It's not even working. I don't know what happened to my... I got distracted. I'm sorry. So, I believe I gave you this question paper. Yeah, I did. I used to know that too, baby, baby. I stoichiometry and air volume. How many cubic meters of air? Answer B. What the? You need approximately. How much is the question? How much sulfur trioxide can be made? Interesting. You want to make 55 tons of sulfur trioxide? 23% oxygen volume excess means simply 23% more oxygen than stoichiometric amount. So instead of 21, it's 23. That's what. O2 excess 20. Not gonna lie, pretty fucked up. 23%, Moles of sulfur trioxide. You calculated the moles, then theoretical oxygen needed. You calculate those. And this part. Mm-mm. If you calculate a volume excess for oxygen of 23%, so 23%. Do you need of air when supplying 23%? So Oh, okay. So we start from. What's the next question? Upon reaction of sulfur trioxide with water, sulfuric acid formed, formulate the reaction equation and calculate which volume of water which volume of water would you need to convert all sulfur trioxide from. Daddy is coming home. Who's daddy? Did you got back? I remember that it's about 9th of September. So is it gonna be today or tomorrow? How is it gonna be? Well, this guy is not on the stream. Mm. Josh Johnson, can you hear me? Today. Okay. Uh, Today, as in night to morning, or have you reached here? Mhm. Sulfur trioxide. So 3. Uh, so sulfur plus oxygen gives. Right now in Vienna. Oh, okay. So you're here. I would say welcome back, Josh Johnson. Clone Open Commander. Yo, not gonna lie, I heard that a lot of people hate chats from two different platforms, but right now I only have two screens, so I gotta make sure I see all the chat. That's why all the chat are in one single chat. All the chats from different platforms are in one chat. Okay, I got 3 more exercise papers to do. I'm doing the last question. And so, us biochemists need to stick together. Yes! Oh! Oh! Biochemists stick together. One of us. One of us. Oh shit. Well, what was I doing? Yeah, sulfur is. Let me pull that up. Come on, show me. Show. Okay. Nerds, don't start a fight, bro. I'm telling you, the biochemistry, we're different breed, bro. It's different, bro. It's none of that AI bullshit, bro. I'm telling you, bro. It's none of this, none of you fucking clankers, bro. We're the real one. We're bio. Uh, sulfur trioxide. Yeah, so that's the stoichiometric coefficient. Coefficient. Uh, 1 sulfur plus 1.5 oxygen gives 1 SO3. Sulfur trioxide. Mona. I mean, did you, Josh Johnson, did you use ChatGPT to write these Monglish slurs? I bet you use ChatGPT. Fucking retard. I'm sorry for you two for the R word, but come on, it's gonna be back anytime soon. Uh, think. 55 tons of 55 tons of what? Sulfur trioxide. I mean, I guess you could get your biochemistry degree and apply for med school. Do you have any students in your class doing that? Ah, I mean, I have a friend who written the exam for the med school and he got into it, but I met him on my biochem. Like he joined this course, then he wrote the med school exam and got there. But yeah, you could say that this person was also doing the biochemistry degree, and then wrote the exam for medical school, went there. But but at least for here they have to do the exam, I guess. I think most places they have to do the exam. 55 tons. 1 ton is equal to 10 raised to 3 kilograms. Molar mass of sulfur trioxide. I forgot. What's the molar mass for sulfur? Periodic. 16. No, 32. mm 32 plus 3 times oxygen, that would be 16. Yeah. Cool. What do you think you will do? PhD or MEd or just find a job after college? I would most probably going for PhD or MD. Like I want to look into more of research and record my research onto my channel. But yeah, that would most probably be my route. But I still want to explore the jobs because you got to pay your rent. uh, 55 tons was 3 times 16. How much is 3 times 16? 48. 80 grams mole per gram. Molar mass, right? Or gram per mole. 80 grams per mole, yeah. Oh, I'm forgetting shit. Solid. I wish my nearest priority would be to get the job based on wet lab or dry lab. At this point, I want to explore both, so I'm ready to do any of those. But dry lab seems a bit more fun because you can just work with the computers. At least for now. Molar mass, number of moles equals 55 into 10 raised to 3 by 80 equals 55 divided by 8. 6.875 into 10 raised to 2. And that's the number of moles of sulfur. That would be the number of moles of sulfur trioxide, and sulfur, just the sulfur is equal because they both require 1 moles of each. Now 1.5 moles of sulfur trioxide is do 1.5 into 6.875 into 10 raised to 2, which would be. Also, I really appreciate people for checking out because, you know, it means a lot. 1.5 into 6.875. That's the number of moles of oxygen, if I believe. That's the problem. Why won't you show this? was the question? Now let's give 23% extra number of moles of oxygen. If I understand, that's how we proceed. How do you give it more? 23%. One point zero. 1.268. Moles is the number of moles of oxygen when you add 23% extra oxygen. Now you found the now you convert it to volume. I believe you used the ideal gas law. PV equals nRT. Ah, fuck, got a lot. And we have all the terms. 335 kilopascal into volume equals number of moles 1.268 into 10 raised to 3. What is R? 0.8314. 8.314. That's it. Wait. Joules per mole per Kelvin. Liter per atmosphere. Fuck me, the pencil battery's low. Typically, PhD programs will pay you if you're worried about rent. That's usually taken care of for the length of your PhD studies. Oh, I heard of it that they would pay you, but until then, like until I complete my bachelor's. After the bachelor's, I believe you have to start with master's, and only after that you could go into PhD or doctorate. But as for the future, I'll charge my pencil, and until that time, I will look into the next question paper. You don't have to do a master's. I didn't. Interesting. So, so what would be the difference between these two, master's and PhD? Like, I know PhD is more of PhD is basically research. That's what I heard. But I heard that you have to do your master's to get into PhD? And you didn't do masters and you did a PhD. That's actually, I'm hearing that for the first time. Uh, PhDs is a longer masters, and typically with the PhD you will publish more. Okay. Yeah, I know with PhD you could publish more, but really thought you have to do bachelor's, master's, then PhD. That's how it. I am in USA though, not sure where you're working. Right now I am in Europe, and I don't know if that's special for USA or it's just my misunderstanding. Maybe it could be my misunderstanding if so how do you start? Are you still doing your PhD or is it over? I think you told me about this but I forgot. So until the pencil is charging, I'm gonna do the other questions. Oh, I mean, nothing to lose, but still, come on, let's just keep it. Let's just keep it. Now that's the exercise sheet 2. I finished my PhD. I have a job now. How long was your PhD? Like how long it took? How long it took? Define enthalpy and enthalpy change in words and mathematically. Why does it often make sense to use enthalpy to describe thermodynamic process of chemical reaction? Uh-huh. Explain the standard enthalpy of formation and standard enthalpy of reaction. What is the standard enthalpy of formation for elements? 5 years for my PhD. So you're telling me they paid you for 5 years to do your studies? So I'm not familiar with PhD. So PhD, is it like just the 5 years? Is it like that's how this PhD is, or it's like your that's how much time it took for you to do it, or is it like the PhD is 5 years? Oh, they wouldn't let me graduate without 5 years. Okay, it's more okay. It's now the numbers are getting similar to med school. Because here my friend has to do 7 years. I mean, he has to study 7 years after he completes the med school. So now this is also getting closer to those numbers. 5 years. Okay, so from what I heard, masters was 2 years, 3 years. PhD is 5 years. But in Europe, I think it's shorter. But still, I mean, the PhD is not joke, no joke. It is. It's really. Could you? I don't know if you're open with talking about this, but would you like to say what did you do exactly as part of your PhD? Like, which subject did you focus? Enthalpy change in words. Change in enthalpy. Change in enthalpy is the amount of heat or energy shift took place inside took place after a chemical reaction. inside a compound. I think that makes kind of sense. Let me see what the GPT has to say. If I understand, enthalpy is the heat change in heat. Yeah, I showed that a single proton changes the oh, changes the orientation of a protein involved in cancer. A single proton. Okay. And what the uh single proton changed the orientation of a protein involved in cancer. Uh, that should have taken a lot of experiments to get close to that statement. A single proton. Makes you question. Oh, now this is really specific. pH matters basically. Uh-huh. pH as in acidity, basicity of the cell. I believe that's what you're mentioning, and that matters. So you did your bachelor's in biochemistry and moved to PhD. A single proton, yes. The molecule I studied showed non-Henderson Hasselblad, or however you spell it, behavior. I mean, I do know a Henderson Hasselblad equation, so that's all. That's all I know. Mm-hmm. Yes, it doesn't follow that equation. Uh-huh. So the deeper you go, the complex it gets. So the importance of proton is that much more interesting in the body. Uh-huh. Proton. Yeah, yeah, nucleus is different. Okay. Proton is the positive. Uh-huh. Damn, it makes you think. It makes you think. Delphi. Delphi is the measure of total energy. Okay, heat the energy of a thermodynamic system. It includes the internal energy of a system, all microscopic kinetic and potential energy of the molecules, plus the energy required to make space for the system by displacing its surroundings, pressure, volume. Oh, okay, those are also in Delphi. So enthalpy is particularly useful when dealing with processes at constant pressure. Mathematically, enthalpy equals U plus PV. Internal energy, pressure of the system, volume of the system. Enthalpy is the measure of total energy of the thermodynamic system. It includes the internal energy of the system, all microscopic kinetic and potential energy of the molecules, So kinetic energy do this. I want to ask this question, but I know it's not that important. So, kinetic, as in the motion of the molecule. When you said proton, I'm just curious. Proton. Ah. Okay, it's found in the nucleus. I mean, every sort of molecule, atoms in the cell should be having a proton, or having a particular number of protons. And single photon. Oh. pH of a buffer solution by relating the pH to the acid dissociation constant and ratio of its conjugate base to peak acid concentration. Okay, I mean, this is just the equation. How it's related to the body, I think you should dive deeper. Yes, when we talk about microscopic kinetic energy and internal energy, it's the energy from translation motion of the molecule, rotational motion of the molecule, vibrational motion of the molecule. All these forms of kinetic energy at the molecular scale, and the microscopic potential energy mainly comes from intermolecular forces, attraction, repulsion between molecules, chemical bond energies. Together, these make up the internal energy, which is part of enthalpy H U plus PV. Oh, so enthalpy would be define enthalpy and enthalpy change. Enthalpy is the amount of heat transferred. Enthalpy is the amount of energy inside a thermodynamic system. Total energy. So enthalpy change would be amount of heat transferred to or from a system at constant pressure, okay? Why does it make sense to use enthalpy to describe thermodynamic processes of chemical reaction? Because most of the factors that involve in a chemical reaction are involved or contained in enthalpy. I don't know. I think that's. Let's see what they got to say. I can't. I did register. Why enough is useful? Most reactions happen at constant pressure. Lab experiments and industrial processes are usually carried out in open containers or vessels at atmospheric pressure. At constant pressure, the heat exchange with the surroundings is exactly the enthalpy change. Most reactions happen in constant pressure. Okay. I did not think in that way. Lab experiments and industrial processes are usually carried out in open containers or vessels at atmospheric pressure. At constant pressure, the heat exchange with the surroundings is exactly the enthalpy change. This makes enthalpy the natural variable for describing reaction energetics. Direct connection to heat flow. What we often want to know is whether a reaction releases heat or absorbs heat. Enthalpy change tells us that directly without having to separately track work done by expansion or compression. State function. Enthalpy depends only on the current state of the system, not on the path taken. Path taken. This makes calculations and tabulations like standard enthalpy of formation straightforward. Okay. Constant pressure. Direct connection to heat flow. Direct connection to flow of heat. The state function, current state of system, not on the path taken. This makes calculation and tabulation straightforward. Tabulated data available. I think the first two are the most important. Enthalpy is the right tool because under constant pressure, which is typical condition for a chemical reaction in real life, the enthalpy changes exactly the heat exchange with the surroundings. Okay. Explain the standard enthalpy of formation and standard enthalpy of reaction. Explain the standard enthalpy of formation and standard enthalpy of reaction. Standard enthalpy of formation is the enthalpy used to form the required chemical compound. The reaction is the change in enthalpy. Oh, one mole. I forgot the moles. Clonopin Commander, if I may ask you a question, like you said last time, proteins, uh, proton changes the orientation of protein. So, if I understand, these proteins are made of, at the end of the day, atoms, and these atoms should be having protons. So, we're talking about how the protons inside the atoms used to arrange the proteins decide the orientation, or has big involvement in, has is highly involved in the orientation of the protein. So so what makes the protein, okay, I mean, makes sense. The proton has high. If you keep the protons fixed on the protein and only modulate the proton on the target molecule, it changes the orientation. Ah, okay. So it doesn't even have to be the it doesn't even have to be the protons inside the protein. Showing that the cell may use pH to control protein behavior in the single signal cascade. Mm-hmm. Okay, I should say I didn't understand everything, but pH does play a huge role. Proton does play a huge role. I understood that. Mm-hmm. The standard enthalpy of formation is the enthalpy change when 1 mole of compound is formed from its constituent elements in their standard states under standard conditions. 1 mole of compound is formed from its constituent elements in their standard state. Oh, that's the enthalpy of formation. Standard conditions are these. So how much energy it's how much or enthalpy changed noticed when 1 mole of the compound is formed from its constituent elements. Mm-hmm. Standard enthalpy of reaction. Standard enthalpy of reaction is the enthalpy change when a chemical reaction occurs with all reactants and products in their standard states under standard condition. Okay, that's just standard. What is the standard enthalpy of formation for elements? Wait. I know this. What is the standard enthalpy of formation for elements? Zero. I would say that would be zero. Yeah. By definition, the standard enthalpy of formation of an element in its most stable form at standard condition is zero. We're talking oxygen gas, hydrogen gas, carbon dioxide, graphite gas. What else? Diamond, nah. Nitrogen, no, there is nitrogen. Water, I believe water should be. Water is zero. Oh, I don't think it's zero because hydrogen and oxygen, nah, it's not zero. Gotta go to my Reddit just for a minute. Enthalpy confuses me because it ignores entropy. Yeah. Uh, Entropy was mainly internal vibration. And entropy, I think enthalpy could include entropy. That's possible, I guess. Thus, could we say, I'm asking an AI, entropy is included in enthalpy? Nope. Measures degree of disorder. Mhm. So ice should be having low entropy and enthalpy. Not necessarily. No, not internal combustion engine. Come, what the? Solid form of water in general should be low energy, highly ordered phase. Enthalpy is basically Boltzmann killed himself because no one believed he was right about how to calculate. My man gaslighted himself into disintegration. Boltzmann. Oh no. No, wait, it's an Austrian. Okay. Right now I'm in Austria. Austrian mathematician, and are we talking about this guy? I think it's this guy. Equation is equal to K. Boltzmann constant. Boltzmann equation tells us that clouds' entropy is related to the vast number of ways those molecules can be arranged. It depends on how many ways the molecules can be arranged while still appearing as a single cloud. So we're so so right now we're talking about how many ways the clouds, at least how many different ways the molecules can be arranged. That's the number of entropy. Yeah, statistical mechanics. Is that what do you talk about, Kay? Entropy was what did I read? Disorder, disorder, or yeah, disorder. Statistical mechanics was a course I took, one of the hardest classes in my opinion. Statistical mechanics, those are like two different terms. Like statistics, math, mechanics, physics, I believe, and statistical mechanics. Interesting choice of. What was the Boltzmann equation? Entropy equals Boltzmann constant into log of W. What was W? Or is the number of microstates? Microstates, I actually don't understand what the fuck is microstates. Number of possible ways the constant particles of a system can be arranged. Oh, that value. How do you get this value? I mean, from what how I think it's really hard to get this value. Microstates. Oh, you don't take me to Gemini? Could you give Okay, using statistics to understand basically any sort of phenomenon or uh, a work. It's not necessarily a course to be a chemist, but it's only if you really want to understand what is happening fundamentally. Yeah, I mean that the more you study, the more it gets like, oh, what? Why is that? What's this? What's the... Sometimes you just gotta look in a different direction, and statistical mechanics. That is an interesting way to look at these stuff. Working on averages, big trends, just samples of things to understand the whole. Using statistics basically to uh, no, this shows that they a lot of stuff follows a lot of patterns. It's all about patterns. You know, this thing is so high rank. You know, this last sentence, it's a prime example of ordered structure that arises from spontaneous process that increase the total entropy of the universe. I when I read, I think 2 or 3 days ago, I read that entropy keeps on increasing. After each simultaneous process or reaction, entropy just increases. What? What? But yeah, it just keeps on increasing. Like, what's the proof? Like, proof. It's just that was such a weird thing to read. And here it is again. I'm not reading this right now. Whoa. He says what was that saying? Standard enthalpy formation stand. Explain the standard enthalpy of formation and the standard enthalpy of reaction. Standard enthalpy of formation is the enthalpy required to form 1 mole of the required compound from its constituent atoms or elements. Constituent elements. What is the standard enthalpy of a formation for elements? What is? Oh, Ziva! Ziva! Uh, for elements that exist in stable standard conditions, the enthalpy of formation is zero, because they exist on the standard condition, so they would be the starting point, or zero. Hess law, calculate enthalpy of reaction for the formation of C2H2. What is C2H2? I forgot. Using the equation below. What was C2H2? No. It was something else. I think I know this. How to solve this question. Just blick, 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 blick. You just skip, just turn it back and front and back and front and back and front. It's just like a math equation. Kirchhoff's law. Calculate the reaction enthalpy for the following reaction at temperature 300 degrees Celsius. And in your calculation, consider the following temperature dependency of the molar heat capacity. Calculate the reaction enthalpy of the following reaction at temperature 300 degrees Celsius. To calculate, consider the following temperature dependency of molar heat capacity. You know, I could give it. I could give this answer. I mean, I did answer these. Well, you gotta do the integral. Kirchhoff's law helps in calculating the enthalpy change in reactants and products with the change in temperature based on heat capacity of the compounds of elements involved in the reaction. Delta HT2 equals delta HRT1 plus T1 to T2 integral of heat capacity. T2 minus T1. Calorimetry, that's pretty good. Adiabatic. You know, if I think if I do all these questions, I should be good for thermodynamics exam. But the problem is attention span. You know how I gotta fight attention span? I should take a 5 minute rest. That's how I should cook. I do have to cook. Oh shit, I actually have to head to grocery store to get some canned sardine. And I have to cut my beef. Well, YouTube, I'm end the stream up here. And I have to head to the grocery store to get some stuff. I'll be back and continuing. I think, yeah, first let me finish this because I have the exam tomorrow. Peace out, YouTube.